Thank you very much, and it truly is a pleasure to be here amongst many colleagues, many mentors of mine, people I respect dearly and looked up to, as well as the next generation of scientists and policymakers who I think are going to take us to the next level of sustainability and sustainable fisheries. And so where I come from, of course, is as a conservationist, is oftentimes my role is to ask difficult questions, bring up subjects, and engage in dialogue. And I'm really looking forward to that. I've had some great conversations already today. Looking forward to speaking more with the graduate students tomorrow. And this is my first time actually here in the building at this campus, so it's really a pleasure to be here, and I've gotten a really warm welcome so far. I'm going to talk today, just to give you a quick background, an introduction to Oceana. Spend a lot of time talking about two case studies. One is on Alaska and U.S. West Coast groundfish essential fish habitat, and particularly Oceana's role in that process. And then a case study of a more recent issue pertaining to California anchovy management, and then some concluding remarks. So Oceana is, at least our claim to fame, at least among the conservation community, is that we are the largest international nonprofit organization that focuses solely on ocean conservation. So we've recently expanded into several offices throughout the world. We're now in 11 different countries that manage over 40% of the world's seafood landings in terms of wild capture fisheries. And so you can see we are a team of scientists, communicators, we have attorneys, and we basically tried to put together an understanding of the law, the science, and engage the public in the media in terms of communications. And we use each of these things to influence change and ultimately to bring fishery management, but also ocean management into more of an ecosystem-based and more holistic way of thinking. And so most of my work in the talk, in my talk today is about fisheries. We also deal with a number of other issues like seafood fraud, oil drilling, and many other issues pertaining to ocean uses. But I'm going to focus today largely on fisheries, and hopefully you can get a better understanding of what the role of NGOs are in the policy process. I do think our role is a very important one, just as many other stakeholders in these policy processes that is sometimes overlooked. And I see both the constructive disruption is a role that we can play, as well as actually constructing solutions, and that's really, I think, a big part of the story that I hope to tell. And in terms of the values of our organization that I think are actually quite broadly shared with many policymakers and members of the fishing industry, as well, is that healthy oceans and fish stocks are really a good thing all around for fishermen, ecosystems, wildlife, the people that love the ocean, the general public. We're very much into promoting people eating more sustainable seafood. In fact, our CEO, Andy Sharpless, has a book called The Perfect Protein that really espouses wild-caught fish as one of the ideal sources of protein, both from a health and an ecological perspective. One of our goals is to see vibrant fisheries and thriving coastal communities, and we do largely embrace a precautionary approach in terms of how we approach issues of low or uncertainty, and when you don't have all the ideal data that you might want to fit into a model, for example. We tend to focus our conservation strategies on this idea of cost-effective management, right? If we have a conservation goal, how can we get there with the lowest possible cost? And a lot of times that can result in even win-win scenarios. And we ultimately believe that better data and both providing incentives to get more data and getting data ourselves will actually enable greater harvests and reduce risk to our systems. And so a couple of the questions that I was asked to talk about today as part of this series, how do we actually go about managing fisheries and conserve ecosystems when data are limited? And how can the precautionary approach be practically implemented? And so this is, I think, an interesting area where, I certainly have an academic training, but largely it's about, this talk will be about putting some of these concepts into practice. There's a lot of lip service about these ideas, but how do we actually go about doing this and actually breaking new ground? And when frameworks may not exist that are out there already to solve problems, actually developing and building some of those frameworks. And so I'm going to take you a little bit through that. A lot of the work that we do is focused on influencing fishery management councils, and I just wanted to point out these are really the main engines for how we manage fisheries in our country. They were established by the Magnuson-Stevens Act. These councils, which are made largely of agencies and state governor appointees, make recommendations to the National Marine Fisheries Service and the Secretary of Commerce, which ultimately decides whether to approve those recommendations. They have multiple management teams and advisory bodies, and the bread and butter of what they do is focused on fishery management plans, which is really a way to take a holistic view of a fishery. And one of the important pieces, and this is where some of our work is on actually responding and listening to public comments. So let's dive right in here. This is the very first issue that we worked on, which has, for me, coming from rainforest ecology, just kind of been a mind blow. When I first heard that there were deep sea corals, hundreds of feet down, I actually didn't believe that was true. I thought someone was lying or making that up. And learning about the uses of these habitats that are on the seafloor, that the seafloor, despite what many people imagine is just kind of a barren wasteland of mud, in many places is thriving with living structures that are important both for biodiversity and housing lots of different species. So if you care about that, it's important to think about these places, as well as actually the habitat use by fish that are commercially and recreationally harvested. Christmas tree coral is kind of one of the poster child species here, and largely because no one even knew this species existed until 2004 when it was discovered off of the Channel Islands in California. A cousin of the Christmas tree coral, which is a type of black coral, the Leopathes, was actually dated with radiocarbon dating, and I actually was able to participate in some of the collection of that coral, to be the oldest known living animal in the ocean, over 4,000 years old, based on the radiocarbon dating of this colony. And what was, I think, also compelling about this is the idea that we're still discovering things out there, that there are still mysteries that we have yet to unlock, and at the same time discovering that some depleted rockfish species, in this case widow rockfish as well as square spot rockfish, were actually documented in close association, the juveniles, with this species. So these fish associations is really kind of the core of the concept of essential fish habitat, right? The idea is that that these habitats ultimately, somehow in ways we may not fully understand yet, are actually related to the production of fish, right? We, as ecologists, we know very well that fish are not just, stocks in the stock market that just go up and down. They don't just come out of nowhere. And in many cases, many species, need these places for hiding places where they feed, and this is a critical part of their life history and survival that ultimately enables the production of a lot of these species, in addition to many other types of habitats that are out there. So the concern that has been raised and came out of many years of scientific literature back pre-2000s and to date is largely focused on the potential consequences of fishing gears that we use to catch a lot of these bottom fish or ground fish, as well as shrimp and other species that actually could drag along the seafloor. So this is a kind of a artist rendition of what a bottom trawl type of fishing gear would look like. And trawling, both in the U.S. and worldwide, is the main way that fish are produced. I think there's some estimate, if you include pollock, that around half of the U.S. seafood wild caught is caught with some sort of a trawl. So the concern is that this not only may not be a selective gear, and that it may not catch just the target species, but also other types of species as well. So there's bycatch concerns, but particularly in places where you may have these long-lived habitats that are important for biodiversity and fish, there could be severe adverse consequences. And this all came to a head in Congress in 1996 when the Sustainable Fisheries Act was passed. And this new concept of essential fish habitat was put into the Magnuson-Stevens Act. And so it required councils to describe and identify what this habitat is, as well as minimize, to the extent practicable, the adverse of fishing on essential fish habitat that's caused by fishing. The extent practicable piece is an important one because there's an implication that it's not to the extent possible, but really that there had to be some consideration of the economic effects and some sort of a balancing act that would be a policy decision to be made here. And the term essential fish habitat was defined as waters and substrate necessary for fish for spawning, breeding, feeding, growth to maturity. And so put yourself in our situation, right? We are an NGO, a conservation group. I arrived on the scene in Alaska in 2002, a few years later, fresh out of college after my first internship. And it was kind of like, well, how do we approach the situation, right? Ideally, we would know every single spot where all these habitats are. We'd know exactly how much they produce. We'd have data on the production rates in terms of different habitats. We'd know exactly where everybody was fishing in relation to this, what it used to look like. But unfortunately, I often describe this as, our understanding and mapping of what's down on the ocean floor. It's kind of like trying to map the forests of North America in the dark at night with the flashlight on, in the fog, right? There really is no comprehensive understanding of where all these habitats are. And so how do we go about moving forward? Right at the time that I came on board, the National Academy of Sciences really put together a compilation of all the science and data that had been collected on the effects, particularly of trawling and dredging on seafloor habitat, and ultimately concluded that bottom trawling does reduce the complexity, productivity, biodiversity of benthic habitats, particularly those with the long recovery times. So kind of pointing in the direction that there could be focal areas that we could look at. And they recommended a combination of reducing overall fishing effort with bottom trawling, modifying the gear itself so that a trawl would have less impact, as well as closed areas. And this is kind of a depiction of several untrawled areas versus trawled, where you see actual evidence of some of this coral rubble after trawls had been through similar habitats to these. So you can see that this was kind of a very controversial issue coming to a head here. So how did we go about approaching this? The idea from the start was to try, how could we protect the habitat while still maintaining vibrant fisheries and coastal communities, right? It would be easy to just do nothing and let it keep happening. It would be easy to take a position of, well, let's just ban all trawling and that'll solve the problem. But how could we actually, is there a way to actually maintain the industry, keep catching these fish while maintaining the habitat that's ultimately producing them? We focused on the greatest threat that was identified from the data and the National Academy of Sciences, and we worked on submitting proposals and data to fishery management councils. We tried to implement a precautionary approach while also understanding what the economic impacts would be to the best that we could based on the data that was available. And ultimately realized that we ourselves needed to gather new science to help solve these problems. And could we set up a situation where we could actually improve the initial set of protections over time? So where we wound up starting was this question of freezing the footprint, right? So you could just say, let's find the best spots where all the corals are that we know about and close those areas, right? That was kind of my first reaction personally. Where are they catching the corals? Let's close those spots. The problem was that if you do that, then the question is not what's closed, but what about the rest of the open areas, and where are these fishermen going to go if they're displaced to catch these fish? And it turns out that you may be actually forcing them into new pristine areas where they may not be able to catch as much fish, so they may need to fish even harder. And so the first step was to really figure out, and this gets to the question of what data was critical, what did we use? Where is the fishing effort actually happening? What is the actual footprint of trawling? So we got these maps that were based on non-confidential data from National Marine Fisheries Service showing different types of fishing gears that were happening. This is an example from the Aleutian Islands. And we started trying to draw these boxes about where is the footprint of trawling. We then realized that in Alaska, there was this amazing data set that had never really been utilized for this particular purpose of this question. Observers had been actually measuring and reporting the bycatch of deep sea corals and sponges for the previous 12 years. And that confirmed that bottom trawling did have both the highest rate and total bycatch. This is comparing rates of bycatch across different fishing gears as a percentage of, or as a rate based on the per unit of target species catch. And so you can see bottom trawling comes to the top, and it also identified the Aleutian Islands in Alaska, where I showed you before. And each of these dots had, that are drawn here on this map, were showing locations where this was happening, and there was a whole bunch of information about that we were able to extract about where these hotspots actually were. The problem, of course, is that this doesn't actually tell you all that you need to know, because this is only for places that are actually fished. In addition to this, there was some of the first ever videos taken by some of the scientists at the Alaska Fisheries Science Center that identified these coral gardens off in the Aleutians. And so these were some of the first images that came out, and we were able to then put those on a map and see where actual, a picture is worth 1,000 words, obviously. And we found that these were extremely compelling, even more compelling than the observer data itself was. And so ultimately what we did to be sensitive, as well as places where research trawls have actually gotten hung up in some of these corals and rocky areas. There was also information and data on highly suitable habitat for overfished groundfish, and we did have information based on where there was high density of some of these corals and sponges, largely from trawl surveys and other observations. And so we amended the approach to account for additional factors that would be indicators that were available, showing us where these vulnerable habitats were. So if you can kind of see the process, there's, we basically got a bunch of this data, put it on maps. We could find, where are different types of known or inferred rock, corals and sponges, different types of biogenic habitats, and then looking at this map here of bottom trawl effort to see, can we avoid these places that are really kind of the runways or the high use areas and protect these places that have sensitive habitats at the same time. Interestingly, as more, when we first made a proposal off the West Coast, there were some large areas that we had proposed, and what the result of that actually, when this started moving forward, was that the industry came back and the states actually allowed what previously was confidential information about the start and end point of individual tows. And so what this enabled us to do was actually refine the proposal, and in fact, on a coast-wide basis, what we were able to do is change the boundaries of our original proposal to accommodate these places where there was high amounts of trawling that we really weren't aware of before. A lot of the data originally was at the scale of these large blocks, and so it really didn't tell you a whole lot. And so being able to see that information and that information coming out actually enabled us to change the boundaries to include more sensitive habitats and more area, and actually lessen the potential economic impact. And the economic impact was an interesting one here too, because how do you guess what a closure is going to do, right? I mean, does anyone really know where, you can guess where somebody might fish instead, and it may be a less valuable fishing area, but we didn't actually, there was no real way to quantify the exact economic impact. But what we could do, and what became the metric of this question of practicability, right, what was being balanced here, was this idea of displaced revenue. So what the agency, what the National Marine Fisheries Service was able to do is look at each of our individual proposed closures and calculate how much revenue annually came from that area based on what was caught in those logbooks. And what we were able to do is demonstrate with this additional data that came forward as a result of confidentiality being overcome in this case, was that the revisions to the proposal, we were able to demonstrate a major reduction in the amount of displaced revenue as the indicator. And ultimately, coast-wide, the agency determined that the overall approach was, quote, practicable and complied with the law based on a displaced revenue being less than 10%. So that became how that legal vague term was actually interpreted. This is what the final council action wound up looking like. We note that a lot of these offshore areas were closed because they were not designated as essential fish habitat, being too deep for some of these fish. But you can see that we basically kind of froze the outward expansion of trawling, and this was a depth-based freezing of 700 fathoms, which was basically the deepest that there had been fishing to date. And then a whole series of protected areas. You also see that ribbon of the rockfish conservation area that was already in place at the time. And so what's really, I think, exciting now is the idea that we could actually improve on this. And so we did we did the best we could at the time based on the data that we had, right? It was not necessarily the ideal solution, but we took a precautionary approach while maintaining the industry. And so now what we're in a process of doing is through the Pacific Fishery Management Council is really looking at how we can improve this with more data. And so we've put forward proposals. The council is engaged in a whole effort to evaluate and bring in all of the new data that has been gathered since 2005, both in terms of the corals, on the fishing, et cetera, and then looking at alternatives. And so now, after about 6 years of this process, the council's set up to later this year take final action on various proposals. So you can see this is the proposal that we have here. And one of the, I think, really neat things about this was in some places where we perhaps were a bit too coarse in not protecting some of the key areas, but also maybe protecting more than we needed to. In sitting down with some of the fishermen, we were able to actually develop the idea that there could be win-win scenarios. So what you're seeing here on this map, this is a map of Monterey Bay area off Central California here. And basically, the green areas would be additional closures, and the orange areas would be places that would be reopened. And so by doing this combination, a fisherman who's familiar with this area is able to look at this map and say, you know, with those changes, I would actually be better off. I'd have better fishing opportunities. I'd get some of the tows back that I lost. And then, you know, and those places that are being closed are less important in terms of actual fishing grounds. Well, at the same time, a conservationist looks at this and is able to say, look, this is doubling the amount of closed area overall in terms of the net. There's twice as much more closures as there are openings, and in terms of sensitive habitats, much more is protected. So we've been able, with more information and dialogue, to increase that. We're also now what has happened with in terms of the data that this process has resulted in is we can compare different proposals to each other. We can look at what's closed under the status quo in terms of different parts of the coast and different types of substrates. And, you know, and just as an example, you can see if this is kind of what's the amount that's closed, there's two proposals that would actually increase the amount of overall protection. And so we've been able to now use data to evaluate proposals against the status quo and across each other. One of the big cornerstones of the proposal is really focused on the Southern California Bight area, where some of the richest coral gardens on the West Coast have been discovered. And notably, this whole area that's in the hash mark is not protected as essential fish habitat, and we're proposing it. And the only places where there's actual fishing going on are in these small pockets near the coast. And so what we've been able to do is work with some of the fishermen to figure out where those lines could be to better freeze the footprint in this area, and also then going out ourselves and doing our own expeditions and getting out there. And so this has really been an exciting part of what we've been doing, realizing we can take this into our own hands and get this compelling footage that can help ultimately show what's down there. And what we've been able to do, we've put together these large reports. We've done 6 of these expeditions throughout the coast, from Washington State down to Southern California now. And we're able to ground truth. These are basically just kind of habitat interpolation maps that were basically just put out in terms of different substrate types, and go ground truth those, documenting additional fish associations with some of these corals, and really just characterizing what these habitats look like. This is one of the really cool things we found, these live shark egg cases actually that appear to be embedded and attached to some of these gold corals that we found off of Southern California. So pretty neat to be able to discover new things that really people hadn't been aware of before. And so we're really excited about where we've come on this. It's come a long way, and hopefully that's given you a bit of an idea of how Oceana has been able to engage in this policy process and bring things forward. So I'm going to shift now to the forage fish question and focus on California anchovy. And certainly, we bring, I think, a perspective here, and forage fish is kind of one of the, I would say, more challenging species to think about in terms of management for many reasons. And I think we have our interpretation of the data, and I think we've gotten into, I think, some really important dialogue and instigated some very important dialogue about how we look at some of these species. In many respects, forage fish were thought to be, some of the most, resilient. They don't need as much management because they can rebound so quickly. But new science is also showing that they can actually decline very quickly as well. This was actually put together based on predators of anchovy. So another important database that we've been using is a new predator diet database that Julie Thayer and others at the Farallon Institute have put together. And what's interesting is it's shown that the California anchovy, in terms of just the number of species that eat it and the importance in their diets, is probably the most important overall forage fish in the California current, which is some pretty neat stuff that's happening. At least it's in the top 3. An analog to this freeze the footprint concept was something, I'm not going to get into this a whole lot, but this was really how we've chosen and pushed forward implementing a precautionary approach. And the West Coast and Alaska, I think, are excellent global examples of how this can be done. And really, the idea here is that these species are so important, and we don't know enough about them in terms of their ecosystem value and what it might mean to fish them. That krill, for example, was something that in 2009, after several years of work, became a prohibited species. And so even though there was a whole required calculation of how much krill could be sustainably harvested, the policy decision was that the optimum yield for society, the best use of this resource, is to leave it all in the ocean. So actually the optimum yield is 0. And so this became a prohibited species then, and there wasn't a fishery already existing for this. And then the question was, well, there is this whole wide group of other species that the council spent several years working on. The idea was they're not being fished yet. Let's prevent new directed fisheries on these species until the effects can be evaluated. And so the diets on kind of what species were in this category was really the critical piece. And I've been working with Lauren Cohen and Tim Essington's lab on actually kind of quantifying how much this is, and we've come up with estimates that these protections actually cover roughly 70% of the standing biomass of forage fish in the California current. It's been, I think, well established, especially for forage fish, that just kind of typical maximum sustainable yield management may not work, or may have some deleterious consequences. This is a paper, just want to point out a paper from Carl Walters and others that kind of came up with what happens when you do look at MSY applied across a whole suite of species, and really push forward this idea of protecting the forage species where they saw this very highly pronounced. And one of the background things that makes this, I think, a very challenging scenario is, and you can kind of look at this and see different things from it, but this is a hindcat looking at scale deposition of anchovies, looking back basically almost 2,000 years from the Santa Barbara Basin, where you actually see, in the complete absence of a fishery, this population of anchovy going through wide natural fluctuations, right? So if this species can crash and bounce back on its own, even in the absence of fishery, of a fishery, does it even matter if we fish the stock? Is this so robust that we may not be able to have an impact? And so while you can see, a stock like this can be very highly productive at times, which the traditional knowledge is well, these are going to be the least vulnerable to overfishing. They can also crash very quickly and remain very low for extended periods, which actually could make them more susceptible to collapse. So compounding a natural decline with fishing pressure on top of that could actually make these species more at risk if they're not productive. Tim Essington and several others from here really, I think, put forward what I would consider a seminal paper on this, kind of compiling a lot of the information, where you actually look at, the question of, is it fishing or is it just the environment, right, that's causing these collapses, right? What caused the sardine to collapse, for example, back in the 1940s and 50s? It's been a kind of an age-old debate, and really the question is that and where we've landed on this as well is that it's really the combination of the two, right? You may be able to fish these stocks at a sustainable level when they're very productive, but when a stock's in a natural decline, fishing can actually make that worse. And oftentimes, because of the difficulty in detecting these collapses early enough, as well as how quickly that can happen, you often see this pattern of high fishing pressure right at the time that a stock is actually collapsing for purely natural reasons. And so the policy implication is, if you actually stop fishing well before the stock gets to this kind of danger zone where this type of dynamics can happen, this is setting a high cutoff at about 1/2 of the average unfished biomass. minimizes these risks while also maintaining high long-term catch. The idea being you can fish these stocks really hard when they're booming without a whole lot of impact, but where the real impact is when they're on a natural decline or at low levels. That's when you can really affect the population dynamics of these fish. And what I find most interesting about this, and this is, I think, just from a human psychology perspective, a very, very interesting question in terms of just social science here, is that the management of California anchovy back from the 1970s through the early 90s, when that fishery was, the last time it was really booming, it was a large reduction fishery. And what you're looking at here is what's called a harvest control rule, for folks who aren't familiar with it, where basically the biomass of the stock is on this axis, and depending on what the biomass is, that tells you what the catch limit is. And so this is kind of this critical idea where if the stock was below what they call this cutoff of 300,000 tons, there was really minimal fishing, right? And fishing shut off altogether when it was below 50,000 tons. And the way that this actually, where this came from, is there was a whole analysis of the effects of the fishery on brown pelicans. There was a definitive relationship that was established between the endangered brown pelican and its breeding success and the biomass of anchovy, because anchovy is such an important prey item for this species. And so this was actually selected after analyzing, the Pacific Fishery Management Council analyzed a whole suite of different possible rules. So you can see if the stock's really abundant, you can catch pretty high, up to a point where basically you're limited by fishing capacity, not by the amount of fish. And this was really put in place very much ahead of its time. The issue, though, happened, and this is where the psychology comes in, is that after the fishery kind of declined due to largely what people largely consider natural fluctuations in the relative biomass, the basic management that I just described was put on a shelf. And so the idea was we should really be prioritizing our assessments and our management of these species based on the ones that are important for a fishery. So sardines basically started to come back, and anchovy became what they call a monitored stock. And what this basically means is that we're only going to monitor the landings. Let's just see what comes in, and we'll stop assessing the species. There hasn't been a stock assessment of northern anchovy off of California since 1995. And let's basically look and set a constant quota and look at the historic levels that were maximum sustainable yield, cut that down by 3/4, and basically just kind of put it on the shelf until there became interest and until that quota started becoming hit again. So if you look and compare what this looks like, this is the old harvest control rule that was in place in the blue here. And then what happened was that became replaced by this red line. So we're not even going to look and ask what the stock's doing. Regardless of where the stock is, no matter where it is, the red line is the quota. And so if you're at really high biomass, that's a lot lower. That's very conservative if you're at high biomass. The real problem comes is over in this area, when you're at low biomass, it's actually a lot less conservative. And it's actually allowing harvest at a time in the stock cycle where it's much more susceptible, and its dynamics are susceptible to fishing exacerbating those low numbers. And what's interesting about this whole situation is the scientist Alec McCall, who used to do the assessments and base those on Southern California eggs and larvae, basically came out of retirement and put together a continued time series showing that basically this was kind of the last year that anchovy was assessed. After 2010, there was a major collapse in this stock, and basically found that the current levels are roughly 3% of the average biomass that we saw before. And so what's interesting about this is it's how are we setting these numbers? The biomass and the maximum sustainable yield were set at a time when the population was booming. So we basically took this biomass and this maximum sustainable yield level and and basically said, well, let's just cut it in by 3/4, and that's pretty precautionary, right? These latest numbers that are coming out of the more updated science are 98% below that. So 75% uncertainty buffer sounds pretty precautionary until you think about a stock that could drop very quickly to 98% or more. And so that's really the concern. And the psychology part of this is that a lot of the people that were around back in these days, right, all the managers that were around there that established this rule, including the scientists, they've all long retired. And so it's kind of interesting, the idea of the span of a scientist or a manager's career versus the timeline of these natural decadal oscillations in some of these fish species. And so now we're kind of at the question of what do we do? There's also other sorts of data that we find very compelling. We don't know exactly what this is telling us, but what it does tell us is there are a number of warning signs. There was there was an unusual mortality event of sea lions since 2013 that's continued over the last 4 years. And recently, scientists at the Southwest Fisheries Science Center pinned this decline on the inability of pelicans to find anchovy and sardines, their main prey sources. And there are a number of other species that have shown signs of food limitation, including the brown pelicans, the common murre, Brandt's cormorants, California least terns. So these species that depend on anchovy and sardines are showing signs of food stress, which is kind of another data point for us showing that we may be in a dangerous place, even though we don't have all the data we need. We don't know exactly what the stock is right now, but we know that we do know that there are many signs that are all pointing to the stock being at low levels. So what we've basically said in terms of our recommendations is that the fishery is likely well below this 300,000 tons. I mean, if there were 300,000 tons, we would not be seeing a lot of these warning signs that we're seeing. There's evidence of stock collapse and predator starvation. The stock is likely well below what a reasonable cutoff would be, which we think is critical for managing species like this. And while there are some signs recently in the last couple of years of some potential recruitment events, there have been some signs of whales eating, aggregation of whales eating anchovies in Monterey Bay. Fishermen are seeing larger schools than they've seen recently. It's still highly uncertain, and until that really becomes clear and evident that there really has been a recovery or recruitment, we err on the side of precaution. We ultimately don't think that the uncertainty buffer that would allow us to just leave this on the shelf is precautionary enough for a stock that may drop well below where that buffer is. But ultimately, what we hope to see is let's get out of this debate and controversy of what to do in the absence of data, and hopefully if we can actually provide some incentives to restore and get back into active management. How do we go back and learn from these experts that figured out this amazing management regime 30, 40 years ago? Maybe perhaps we can look at that as a starting point, but the fishery probably will look very different. So we've been pushing to get better data. Let's get better stock assessments and better ways of surveying these populations beyond just counting the eggs and larvae. Let's look at what a new harvest control rule would look like that actually accounts for predators as the one that did before. Importantly, is there a way to detect and respond to the stock collapse? One of the cornerstones of fishery management is to know when a species is overfished or depleted. So what's the trigger for rebuilding? Without any way to know that, that's really an important kind of fundamental piece to this. And we also do think that it's time to start thinking about time and area closures to protect predators. It may not be just the low numbers of anchovies. It may be where they are in relationship to the breeding colonies and these predators that where the mothers basically need to locate anchovies or sardines nearby to where they're trying to nurse their young. And if they can't find them, they basically have to abandon them, which is basically what has been happening here. So thinking about these is where we're pushing and where Oceana's perspective is. And what we have seen in the management process is a much more attention to this. There is a commitment to do a stock assessment. They're actually, the council's now thinking about putting more ecosystem experts into the management team that manages anchovies, right? Should we be thinking more about more than just this single species when we're deciding its quota? What other things should really come into this? And so we are optimistic that we are headed in a positive direction here. So in conclusion, hopefully you've been able to see a few of the ways that we as an NGO have played a role in the fishery management process, right? We haven't gotten, of course, everything that we want, but I think what hopefully we've been able to do is to bring forward new information in a way that maybe it hasn't been looked at before, bring in other perspectives, because I think that there are many different types of values in the fishery management world, and we bring an important one that is part of a larger process. In the absence of data, a precautionary approach, especially for new activities that haven't started yet, makes a lot of sense, particularly if there's a way that ultimately in the future activities can happen as long as they're accompanied by the data. And so that's really what we've been pushing. It's not that some of these closed areas have to be closed forever, but data needs to be gathered in order to reopen them. When the ideal data isn't available, make the best use of the data that does exist. And this may require you inventing an entirely different framework than the one you might be used to, right? Many of the frameworks in fisheries are very data hungry. So maybe there's a different framework, and there's a lot of work now in data poor management that can provide some different frameworks for that. Providing incentives to share and collect new data. Remember when we kind of shifted the discussion of open and closed areas, right? Data that was very highly confidential and tightly held became released because it was in the fishermen's incentive to release it. And ultimately, we've also seen that the better, finer scale data you have, you can become more cost effective. You can have more protections of the ecosystem while also allowing greater levels of harvest and extractive activities. And ultimately, our latest tagline is that we do believe that saving the oceans can help feed the world. So I wanted to thank the organizers, thank everyone. It's been really a pleasure being here, and a lot of work from my own organization and many conversations with fishermen and managers, and again, all my mentors here in the room. And so hopefully we have some time for some questions. Thank you very much.
Thanks, Geoff. We have time for questions. I should check.
Oh boy.
I don't want to say anything that gets me or you into trouble, so I won't do that. But I guess the one thing that I didn't hear from you, that I hear from 10% of people who put themselves in the conservationist box, is ecosystem-based fisheries management, and we should throw out the paradigm, and we should get holistic and integrative and transdisciplinary and all sorts of words I don't understand. You didn't mention that whole paradigm shift. You were doing the same ideas that fishery scientists have been doing for the last 100 years. Why didn't you do that? Why didn't you say we need to do ecosystem-based fisheries management? Why do we want this whole single species stuff?
Thank you. That is a great question, and I guess the first thing that comes to mind, hopefully I did say that is kind of the goal of the organization at the beginning, right? That is kind of ultimately an underlying driver. I guess in many respects, I have the same kind of concept of that term that I think that you just mentioned, right? It's all this holistic stuff, and it could mean a million different things to a million different people. And what I actually think, that I described here in talking about the importance of habitats to commercial fish and biodiversity, and the importance of anchovies to all these other things in the ecosystem that ought to be brought in, right? That to me is ecosystem-based management. And rather than just kind of starting with that, I mean, yes, we of course believe in that, but it was the same sort of situation with the marine protected area debate, the idea of marine protected areas. You notice I didn't use that term in any of the portion on the essential fish habitat part, right? And largely because that term had a whole set of baggage, preconceived notions, controversy around it. And by shifting out of that framework and talking about basically the same thing, these are marine protected areas, they're boxes in the ocean that certain things are allowed and not. By taking it out of the framework, I think it helps people kind of take a different start and take a different approach to it. So I think that when certain terms are overused that mean too many different things, you know, marine spatial planning is kind of another one, right? Everyone has a different idea of what exactly that is. And actually go, rather than trying to kind of talk about it and create some definition that works, I guess my approach is to be more of, let's just put it into practice. And I believe that this is ecosystem-based management, all the things that we've talked about. But again, I didn't say the word, you're right. Yeah, that's a whole nother side of this debate, and appreciate the question. He's talking about what political strategies do we use. Something I didn't focus a lot on here is the public communications and media strategies, and so that's actually an area that even relative to many other NGOs, Oceana has a large investment in that communication. It's trying to reach a lot of people and get the word out, and you know, ultimately in terms of just, you know, politics, you can kind of put out something that you think is just the right thing to do, but oftentimes, you know, even you know, when you're in a difficult political environment, you're a fishery manager, you're a member of a management council, right? Even if you actually agree with the things that I'm saying, right? In many cases, you need to have some sort of cover, right, to actually go and do the right thing, right? Sometimes, you know, we hear often, you know, we need to see support for some of these ideas, right? So something we're doing much more of now in terms of some of the you know, the forage fish work is reaching out to some uncommon allies, whale watching communities, you know, recreational fishing groups care about these issues, and so going and doing some of that outreach and showing broad support. We have what we call wave makers, where we have all, you know, I think we have, you know, 500,000 of these people that are all throughout the country that we regularly communicate with and tell them, here's a big issue that's coming up in front of a council, you know, weigh in, and you know, we bring in these you know, these large you know, petitions that have, you know, that show that, you know, it's not just that, you know, this many tens of thousands of people want you to do this, it's also that all these people are watching and paying attention. And so there's some sort of accountability there. So I think, you know, what I've seen is it takes some time in these processes. The people that just come in and think that they can just kind of get up on the podium and tell the managers, hey, do this, and that's all you have to do. I mean, there's really much more to it. We spend a huge amount of time going to these advisory council meetings, getting to know individual members of these councils, and ultimately trying to launch more of a holistic strategy that includes, you know, deep science. There's also, I think, the legal aspect, the fact that Oceana does file litigation at times, does enable us to have a seat at the table in many cases when we wouldn't otherwise. And so we basically try to use all of these different tools, and that could be a whole talk in and of itself. Yeah, and that's a great question too. And there are certainly, and I've studied, you know, there are many different ways to assess the value of information in one information versus another, right? And this is ultimately a question that's being asked for the anchovy, right? Is it worth going out and spending all the money to get a new stock assessment given the value of the fishery, right? Is it worth that effort? I think that the way we've looked at it is really kind of, I'd say, a two-pronged approach, right? we have an existing set of data that's out there, right? And that's sort of, exogenously defined. It's out there, there's data. How can we go out and make the best use of that in the context of this is all we have to work with? How can we make the best approach? And if we have good data enabling, very precise management, we do that. But oftentimes we defer to more of a precautionary approach. But I think the critical piece is then when we see what is the missing data that's really impeding our ability to be effective here, that's impeding the ability to be cost effective in doing this, right? Because you could, as I said before, it's easy to say do nothing or shut the whole thing down, right? Those are easy approaches. The question is how do you actually kind of thread that needle better? And oftentimes what we do is what is the missing data, right? When we saw, for example, that the video footage from those coral gardens gave those places that had video footage higher levels of protection than other places, we realized we need to do this and take this on our own and invest our own resources in doing that. And also it's part of what we do is in the event that we're not getting the data we need to solve a problem, potentially the problem could be more severe, right? We're working with this issue now that's come about there's been a big spike in whale entanglements and fixed fishing gear off of California in particular, although it is a coast-wide problem. And the question is, we could get much better data on, for example, the co-occurrence between fisheries and where these whales are. And if we had better data, we could be very targeted about that. But in the absence of that, we're kind of left with, large swaths of area that could be closed. And so, making sure that becomes clear, and sometimes, threatening that may be an outcome of, doing nothing and not collecting data, really does shift the incentives. And that's really, I think, where we look at it. When there's a situation where the fishing industry does not want to collect or share data, it's kind of a red flag for us, right? Why not? And if we can change the policy so bringing forward that data could make much more targeted measures that are not so draconian in their effects, that's how we've approached it. Yeah. Yes, sure.
Ask me to tell us in a general way where Oceana gets support that scale of research.
And just on that research vessel, we borrowed it, so that wasn't ours. But they did let us paint our logo on it temporarily, which was nice. Yeah, about 75% of our funding comes from large philanthropic foundations. We do get kind of the remainder from individual donors and members, as well as kind of larger businesses and partners in that way. But yeah, largely it's we're writing grants and working with large foundations. And one of the interesting things about Oceana's formation is that we were actually formed by a set of funders and foundations, and several of the large program officers from foundations are members of our board. So it does have a little bit of a different structure than some other organizations. But again, wanted to thank everyone's time and attention, and it was a real pleasure being here today. Thanks.